Okay, let's go through the physics exam, physics revision sheet results. Again, I want to highlight the fact that if you grab the 3 chapters from the Science World textbook and have a look at the review questions, that will significantly advantage you in doing the exam. So, question 1, acceleration of a car moving at constant speed. So the key word here is constant speed. So therefore, if it's got a constant speed, it's got no acceleration. So therefore, it's got to be D, because there is no acceleration. So question 2, which speed time graph is made by an object travelling at a constant speed? So speed time graph, constant speed, is going to give us a horizontal line in our speed time graph. Question 3, which velocity time graph is made by an object with constant acceleration? So constant acceleration means you're going to be constantly increasing your speed, but you're increasing your speed at a constant rate, so therefore you're going to have a straight line, so it's going to be B. Question 4, which speed time graph is made by an object slowing down? So if you're going to slow down, you're going to decrease your speed. Doesn't say anything about doing constantly, so the only one with the one decreasing our speed is C. Question 5, which velocity or speed time graph is made by an object speeding up, then slowing down? So we need to look at something that's got a increasing speed, so that's A, but then also looking at it's got a decreasing speed, so that could be D's got a decreasing speed, but B is the only one that has both an increasing and decreasing speed. Question 6, a bus driver has a trip of 360 kilometres to complete. If the average speed of the bus is 90 kilometres per hour, how long will the trip take? So on this one, B equals 90 kilometres per hour. D equals 360 kilometres. Time equals question mark. So there's our facts. Over on the formula sheet, you'll notice that you've got one here, B equals D on T. We want to find out T, so we cover up T. And we notice there that T equals D on B. So that's going to be equal to D, which is 360 over 90. So 360 over 90, zeros cancel out, 36 divided by 9 gives us 4 hours. So there's question 2. Marks on this one. Marks with facts, marks for solution. For solution. Really, half mark for facts, half a mark for formula, half a mark to find it, half a mark to fix it. Find the average speed if a jet flies from Brisbane to Adelaide in 2.5 hours. So again, B equals question mark, D equals 1600 kilometres, time equals 2.5 hours. So again, V equals D on T with 1600 over 2.5. So don't forget to bring your calculator into the exam because you'll need it. So 1600 divided by 2.5, if I just quickly load up my calculator, go 1600 divided 2.5, that gives me 640 kilometres per hour. A train travelling 5 metres per second accelerates to 25 metres per second in 10 seconds. So train, so we want to find acceleration, so it's question mark. Initial speed is 5 metres per second. Final speed is 25 metres per second. Time is equal to 10 seconds. Acceleration equals final speed. Take initial speed over time. So it's going to be 25, take 5 over 10. So 25 take 5 is going to be 20 divided by 10 It's going to be 2 meters per second per second. So question part B, I either can redo the facts and so forth as there. So what will be the speed after another 5 seconds, or acceleration equals 2 meters per second. Final speed equals question mark. Initial speed equals 25 meters per second. And time equals 5 seconds. And so therefore I can rearrange by writing my formula here. A equals VF, take VI over T. So it's going to be 2 equals VF, take 25 over 5. So therefore we're going to have VF equals 2 times 5 plus 25. So that's going to be equals 10 plus 25. That's going to be 35 meters per second. The other way to do it would be each second increases by 2 meters per second. So time equals 0, it's going to be 25. Time 1 is going to be 27. Time 2 is going to be 29. Time 3 is going to be 31. Time 4 is going to be 33. And time 5 is going to be 35. So you can see there you can do it by just increasing. Question 9. Graham is riding his bicycle at a uniform speed of 10 meters per second. He brakes to come to a stop in 2 seconds. If he and the bike have a total mass of 90 kilograms, find the acceleration of the bike. So we want to find acceleration, so that equals question mark. Next, it says our initial speed. Initial speed is 10 meters per second. Our final speed is 0 meters per second because we've come to rest. People are there, stop. Time equals 2 seconds. So A equals VF, take VI over T. So it's going to be 0, take 10 over 2, so it's negative 5 meters per second per second. So remember, negative in acceleration means it's slowing down. So what do we need? The force. So force, we don't know. Mass, we know as 90 kilograms. And acceleration equals negative 5 meters per second per second. We can ignore the negative sign here because we're just talking about the force, and the force is going to be acting in the same way as acceleration, so we can just do the calculation without there. So force equals mass times acceleration. So it's going to be 90 times by 5. So 5 times 45, that's going to be 450. And the units for force are newtons. A mini and a semi-trailer are both travelling at a speed of 50 kilometres per hour, which require more force to stop it. Justify your answer. So remember, our speed, our acceleration is going to be the same. So acceleration, same for the both, because there's nothing that changes, because A equals VF take VI on T. They're both going to have, they both have the same initial speed. They're both going to have the same final speed. And in this particular one, we're going to assume they both stop in the same amount of time. So the acceleration part is going to be the same for both of them. So what we want to look at is the force is proportional to mass in both of them. So the size of the force is going to be proportional to the size of the mass. So the mini, it's got a small mass. So therefore, it's got a small force. Semi, it's got a big mass. So it's going to have a big force. And so there's the justification to show that the semi is going to require more force. Question 11. The graph below shows change in speed of a car as it travels between traffic lights. So if we're looking at this graph first, so initially it's accelerating, constant speed, and then decelerating. So the car speeds up, gets to 10 meters per second, travels constantly for 10 meters per second for a period of time, and then slows down to stop again because it's come to the next traffic light. So explain the shape of the graph. Accelerate, constant speed, and decelerate. Obviously, I'm going to be expecting you to write some nice continuous prose there. For these, say how long. So tell me how long they're actually travelling for. At what rate does the car accelerate? So we want to find A. So we know the initial speed in this situation is 0 meters per second. We know that the final speed is 10 meters per second. We need to go back to our graph here, and we notice that it's that point there that it stops. So that's 1, 2, 3, 4, 5. So each one of those dashes is 0.2 of a second. So 1.2, 1.4, 1.6, so it's going to be 1.7 seconds. The time, 1.7 seconds. So A equals VF, VI on T. So final speed is 10. Take initial speed of 0 over 1.7. That equals, again, grab our calculator. So I have 10 divided by 1.7. So it's going to be 5.9 meters per second. So I want to write out deceleration, so it's at the end. So A equals question mark. VI equals 10 meters per second. VF equals 0 meters per second. And again, we're going to go back and have a look at our graph, find out the final time. So we start slowing down at this point. So that's going to be at 4.1, 2, 4, 6, 7. So 4.7. And it finishes at 6. So 6 take 4.7. Is 1.3. So time equals 1.3. So A equals VF, take VI on T. So VF 0, take 10 over 1.3. That gives me calculator. What is that? 10 divide 1.3, oopsie, divide 1.3, so it's going to give me 7.7 meters per second. So question 12, again, for those who've watched this, try and share it with your mates. This is the question in the exam. Same with the chemistry question you had earlier in the week. These are the questions in the exam. The question 12 is the last three questions of each of the revision sheets. They are the extended response questions in the exam. So you're not allowed to take anything into the exam, but this gives you a bit of a chance to get your brain thinking and in the right place. So write down Newton's 3 laws of motion, including any formula and so forth. So Newton's first law. Object, rest, motion, continue. rest motion unless unbalanced force. My expectation is that you'd write that out as two separate sentences. An object in rest will stay at rest unless an unbalanced force. An object in motion will continue motion unless an unbalanced force. Second, acceleration proportional to force. Acceleration inversely proportional to mass. So A equals F on M, or F equals ma. Third law, equal and opposite. So every action has an equal and opposite reaction. So F1 equals negative F2. I push on the wall pushes back on me unless I push with greater force. It's just going to hold me there. So design features, so we're talking things like seat belts, airbags, crumple zones, etc. And you can go infinite with that. So you need to write down Newton's three laws. So you need to describe three features. So 3 features there about that. Okay. Thank you.